Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our new tutorial video. So in this video, we're going to talk about solving quadratic equations, which is by factoring. So this is just a continuation with the last video that we had, which is all about solving quadratic equation by extracting square roots. So for today, you must be able to factor quadratic trinomial, or just recall factor quadratic trinomial, and solve quadratic equation by factoring. Yes. So let's proceed. So before we proceed to the main lesson, let's have first a short review on what is a quadratic equation, right? So what is a quadratic equation? Again, a quadratic equation is an equation which is written in a form of ax squared plus bx plus c equal to 0, where a, b, and c are real numbers. So the first term is what we call the quadratic term because of its exponent 2, and the degree of the polynomial must be 2, or the degree of the polynomial is 2. So examples of quadratic equations are this one. So we have here in this form ax squared plus bx, and then case 1 which is complete. a, b, and c are complete. Case 2 also complete. So case 1 and case 2 is referring to this one. Complete quadratic equation, but yeah, a is equal to 1, and the other one is a is not equal to 1. So the first one that I wrote here, encoded here, ax squared plus bx equal to 0, is another form of incomplete quadratic equation, right? So these can be factored or solved using using factoring, right? So these are just some few examples of quadratic equations. If you notice the red marks there, that is the indication that a particular equation is a quadratic equation because of that power or exponent 2. And take note also that the equations uses only one variable. So these are non-examples of quadratic equation. So this one, expression or for z-squared. If you notice, there are no two variables were used. This one cube, this one cube, this one cube. Okay, so first is how do we solve quadratic equation of the form ax squared plus bx equal to 0. So again, this is an example of an incomplete quadratic equation where your constant is equal to 0. So you can solve this kind of equation using factoring also. So how do we deal with that? So here are the steps. First is you're going to use the concept of GCF. So you have to identify the GCF of the two terms. Or sometimes you have to set it in standard form so that you can identify the GCF, right? But more or less, you have to do this one first. Seldom, you can only encounter equations that are not yet in standard form. So if it's not yet in standard form, so you have to make it standard form before you identify the GCF. Next is set each factor to 0. So you apply the principle of zero products, right? So it says that one factor must be equal to 0, either or the other one. Okay, and then after that you solve for x, and also you do the checking. Forget to write the checking. So let's proceed to the example. Number 1. First given is 3x squared plus 18x equal to 0. Right? So if you notice, the constant is 0. So the form is ax squared plus bx equal to 0. So again, if you check it first if it's already in standard form. So all the terms are on one side of the equation, so that means it's in standard form. So you can proceed in identifying the GCF, which is 3x. So how do you get the GCF? GCF means the greatest common factor of every term here. So The greatest common factor is 3x, right? Because 3x is common or present in the two terms, right? So 3x here and 3x here. So what happened? How do you get x plus 6? After getting the GCF, so you have to factor it out or divide it. So now you will be left with x plus 6 inside. So 3x parenthesis x plus 6 equal to 0. After that, you use the principle of zero product. So 3x equal to 0, x plus 6 equal to 0. And then you solve for x, which gives us x equal to 0 and x equal to negative 6. So why is it that it's already x equal to 0? Because if you simplify this one here, you divide 3, right? So this will just give us a 0, right? So that means the roots or the solutions are 0 and negative 6. So for us, just a short reminder, ax squared, a quadratic equation in this form, ax squared plus bx equal to 0, is always, right? So one root must, it will always be equal to 0. And the other one will be any number, any non-zero real number. Right, so if you notice, one root is 0, the other one is negative 6. Right, if it is in this form, okay? Next step is you do the checking, right? Checking is for x is equal to 0, 3 0 squared plus 18 times 0 equal to 0. So when you do the checking, you only have to substitute whatever the value or the solution that you've come up. So x equal to 0, so 3 0 squared plus 18 0 equal to 18 times 0 equal to 0. So basically this will just give us or lead us to 0. So 0 equal to 0. I forgot to write the question mark and the check mark. For the other value, which is negative 6, so let's distribute 3 negative 6 squared. 3 times negative 6 squared plus 18 negative 6 equal to 0. Is it a solution? Let's check. Negative 6 squared, that's 36 times 3, basically that's 108. And then 18 times negative 6, that's negative 108. You can check on that using your calculator if you have one. So basically it will just give us 0. So which means that the two are the solution, right? Next is example number 2, 4x squared minus 2x equal to 0. So again, you check if it's already in standard form. So this time it's already in standard form. All the terms are on one side of the equation. So basically you have to identify the GCF already. So the GCF is 2x. Why? Because 2x is present here and also on the quadratic term. So after factoring out the 2x, you will be left behind with 2x minus 1, right? Because if you try, it's basically like this. When you factor out something, you're going to divide everything by what you factor out. Okay? So minus 2x over 2x. And then after you've already factored out, so you divide, so you'll be left behind with 2x minus 1. And then you equate it to 0. 2x, the factors must be equated or set to 0. So 2x equal to 0 and 2x minus 1 equal to 0. That's because of the principle of zero products. And then you solve, right? So this is basically x equal to 0. And then the other one is 2x equal to 1. You're not done yet. We still have to divide, right? So that's why we have x equal to 0 and x equal to 1/2. So the roots are 0 and 1/2. So again, short reminder, you can read it here. Next, we do the checking. Checking is, again, similar to what we did in the first example, is that we substituted the values. So for x equal to 0, basically, if you substitute zeros here in the x, 4 times 0 squared minus 2 times 0, and that is just equal to 0. And for the next value, x equal to 1/2, 4 times 1/2 squared minus 2 times 1/2, basically cancel 2 here. Then this one is 4 times 1/2, which is cancelled again, which gives us 1 minus 1, right? Equal to 0, or 0 equal to 0. Yeah. Okay, next example, number 3. Solve 11x squared minus 13x equal to 8x minus 3x squared. So this is what I've told you earlier. You first set it into standard form. So this one is not yet in standard form, so we have to make it in standard form. So our goal is to put it on one side of the equation. So here we added something so that this one here becomes 0. So what happened to negative 3x squared? It becomes positive 3x squared, and then 8x, it becomes negative. So next is you combine like terms. So 11x squared plus 3x squared, that's 14x squared. Negative 13 or minus 13x minus 8x, that's basically 21x, right? So 14x squared minus 21x equal to 0. After that, you can now identify your GCF, which is 7x, right? So after that, you divide, okay, and then you're left behind with 2x minus 3. Basically, it's like this, 7x parenthesis 14x squared over 7x minus 21x over 7x. Okay, so next is you equate the factors to 0, right? And then solve for x. So basically x equal to 0, and then the other one is solve for x tayo. So yeah, so x equal to 3/2. So x equal to 0 and x equal to 3/2. The roots are 0 and 3/2. Checking. So for the checking, when you do the checking, you always have to use the original equation. Right? Do not use the second or the secondary equations. For x equal to 0, basically, pag you multiply the x, since all the terms contains x, and then if you substituted x on everything, it will just give us basically 0, right? And the next value, 3/2, no? So 11 times 3/2 squared minus 13 times 3/2 equal to 8 times 3/2 minus 3 times 3/2 squared. So if you simplify those, this one becomes 9/4 because it's 3/2 square. This one is, I just copied it, and then this one also becomes 9/4. If you combine the left side, it will just give you 21/4. And if you combine the right side, it will also give you 21/4. Never mind the size, it won't matter as long as they are equal in value, not the size. Okay? So for practice purposes, you can use the following items, or you can practice solving the following items. For the continuation of this video, you can visit the website, and yeah, for another case of solving quadratic equation by factoring. Thanks for watching, and yeah, thanks for watching. God bless. Stay safe.